Thank you for joining another Mitsubishi Electric webinar. My name is Freddy Marie. Today's webinar will be about the real-time monitoring Works3. I'll be starting the presentation just now in a minute, and it's roughly about 25 minutes long, just to keep track of time. And thank you for attending. And let's get started. Okay, I've taken advantage to start GXWorks for us already and set up a couple of things. I'm working with a live project at the moment, and I'm just going to quickly demonstrate a PID, for instance. So let's say I would like to monitor some data in a PID. So there's my PID function block. I've preset a couple of registers for the PID. On the right hand side we can see the variables of the PID as it's running now actively. We can actually look at the PID running live in the data registers. But I'm going to start from scratch and I'll show you how I'm going about it and what information in the PID I would be interested in. So what this example is in the e-manual viewer. So go and have a look at the e-manual viewer, and you will find the PID documentation. There's 5 examples which you can go and work from. Just get to the examples. There's our examples. So this specific PID is going to be the example in the e-manual viewer, based on the limit cycle method plus PID control. You're more than welcome to go and look at that. What I will do for you is I will copy the link in the e-manual viewer, and I will post it for you on YouTube. And you can just go and copy that link, paste it in your search in your e-manual viewer, like that, and e-manual viewer will take you directly to that page I'm looking at now. Make sure that your e-manual viewer is up to date. Take note that it did not find anything. Be sure to come down here, click under all, and come down and select page search. Okay, so when you click page search and you search again, it will highlight that specific page for you in the e-manual viewer, just to help you to get started very quickly. Okay, so now that way you can look at exactly the same information I'm looking at in the e-manual viewer. So there's the example in the document on the PID controller that I'm looking at. All you need to do is, I've just converted the code into function block diagrams, much easier for me to work with and simpler to understand as well. But if you're familiar with ladder, there's your ladder code. All you need to do is just click on the copy ladder program in the e-manual viewer, and you can go and paste that program in GXWorks. Okay, so there's an example of how to do that. So you can literally just go and select an empty space, open a ladder program, and paste the code into GXWorks3. Okay, and you have a complete functional PID controller. I've tested this code many times over and it works 100% perfect. Okay, so let's have a look. What do I want to know? I know the purpose of the presentation is not really about the PID, it's absolutely about any other information in GXWorks. So what we're going to do is, I'm just using the PID because I would like to monitor maybe some information in the PID. So I would like to know when the auto-tune cycle is completed, and how the bits switch on and off based on how I've written my program. So the program is exactly the same as in the manual viewer. So the idea behind that then is a output on my PLC is going to be switched on based on a time interval of a timer, and the PID is going to drive the output to that timer, and it's going to do a comparison between the output of the PID and the time set, which is a time variable in the PID controller. I'll explain a little bit more about that, but you're welcome to read all the information about the code right here, and it's very well explained. And that will, for instance, switch on my heater. So let's have a look and see how that will all work together. So I'm interested in seeing my auto-tune variable, so when my auto-tune is completed, and I would also like to see my output. In my case it will be Y23 on my PLC. So as my temperature change, my output on my output, for instance, I'm driving a solid state relay, and that will control my temperature on my element. And then obviously the temperature sensor that I use on the element will feed the information back into S2 of the PID controller. I just quickly want to start my zoom tool. I forgot to start my zoom tool this morning because I see you can struggle trying to see what I'm seeing. Yeah, that'll be better. Now we can zoom in. So the idea here is to get feedback from my temperature sensor into S2, and that obviously will be based on my set point that I got on my PID, and this is my initial value, my initial parameter of the PID. Please go and read the help file to understand how to deal with the PID if you're not familiar with the PID controller. So time interval for the PID is 500 milliseconds. My current temperature at the moment there is 10 degrees Celsius, and I would like, 100 degrees Celsius, 100.4 degrees Celsius to be exact. So that's a comma there, and my set point was set for 100 degrees Celsius. Okay. So currently the PID is switched off because my temperature is warmer than my set point. So let's see how this whole thing works. I'm going to show you how the log viewer looks like. It's busy recording information in the background. So I'm going to start a new recording for us so that we can see the feedback from the PID controller based on the data. So I'm just going to stop this now, and I'm going to zoom out a little bit because you can't zoom out too far and you can't scroll while you're recording. Okay, so that's only a little drawback that I got there, but other than that, I'm going to start from scratch to show you how I got to see this information. Okay, and I'll show you what I've just done there now as well in the background, so we can understand what it looks like. Okay. So I decided to add a couple of variables into my log viewer. So in my case, I would like to record variable R30 and R31. So R30 is going to be my, let's confirm that, R30 will be my PV. and 31 is going to be my MB. That will be the output of the PID. Okay, and then I just added the other bits in here that I'm interested in. I'm interested in bit number 4, bit number 6, and bit number 8 specifically. So and also bit number 6, take note that bit number 4 and bit number 6 will switch once your auto tune is completed. Okay? But I would like to know when it happens and how it happens, because that's all now a mystery for me, and I would like to monitor that. So let's have a look and see. And then I've just added my Y23 to see what it's going to do. These are just obsolete variables at the moment. I can actually take them out for now. Let's delete that item. Let's delete that item because we don't need them. Yeah, you can literally just type in your variables that you would like to monitor. And the nice thing about this is if you close it, it will open a new form. You need to repopulate the data. But if you got a set bit of information that you regularly would like to monitor, maybe you got an intermittent fault in your plant and you would like to monitor the bits, which bits switch on either too early or too late, and you can capture that event instantly on literally microsecond timing. And there's a button on top here where you can go and select. Sorry, there we go. Come on. What's going on here now? There we go. So there's your button, read from file, and the other one at the bottom will be oh goodness, what happened to my mouse? Come back, there we go. And the other button will be save to files. Okay, we can zoom out now. Now I've got a problem with my mouse. What is this now? The zoom tool doesn't want to go away. Come on. Play with now. Let's see. There we go. That was not nice. Let's try again. So basically when you close your real-time viewer, I'm going to close that now for us, and then you'll find the real-time monitor function in here, or you can start it separately as an independent program. And then you just have to make a connection to whatever PLC on your network you would like to connect to. Okay, so then I start the real-time log viewer. Okay, it's going to tell me that it's going to do an automatic connection. It's going to search for a PLC on the network, and there's my blank list. Okay, so because I did save my file earlier, so I'm just going to go and read my file back again, and I called it demo, and there's my demo file back. Okay, so I just don't want those 3 variables, and I can go and delete them, and I can save it again as demo 2, for instance. Okay, so I don't have to repeat myself on that. And all you need to do is just push the start monitor button, and you're on the go. There's a couple of buttons on top here that you need to be aware of. When you're monitoring analogs like I'm going to do here now, analogical values or word, double words, maybe you want to monitor your high-speed counter or any variables like that. These buttons here will reformat your chart. because it will just stay stationary in one position all the time until you expand the chart to see the data on the chart. And we'll see that just now happen. Okay, so before I start that, well, we might as well start that, and then I can just go and set everything to default. Okay, so we'll get back to the log viewer now. I'll leave it in the background there. And on this side, we got our PID still running happily. And I'm going to stop everything now with the bits programmed in my application to stop my PID from working. So I can go and have a look there and note that my PID has stopped operation. And the log viewer obviously has recorded that in the background. I'll get all that together for just now in the PLC, and I'll show you on the PLC what happens there. Any questions there in the meantime? So if you've got any questions, you're welcome to ask me. Eh? So let's see. I'm going to reinitialize my PID. I've got a little program in the background that's going to initialize my PID to set everything to default. Okay, so all of that has happened. So my PID must be populated with a couple of variables, otherwise it's going to fail every single time you try to do auto tune. So at the moment the PID has collected preset parameters. I'm going to zero them for us, just to show that the auto tune did work. Okay, so that was my proportional gain, and this is my integral time. I'm making them all zero. My differential gain is zero, and my differential time also makes zero. So these are the values that I don't know on how my temperature sensor work, or how my PID would heat my element. So the PID will go and do a quick test on the element by pushing it over a certain limit. So I've set my hysteresis threshold to 50, which means it's gonna run for a certain percentage of my set point. Okay, and I think that is 5% of my set point. So it should just go over my 100 degrees Celsius, and then it will go back down again to below my 100 degrees Celsius, and it will do that for about 3 times because it's set into limit cycle. So take note, if my bit 6 on my PID is set to 1, then the PID is configured to be in limit cycle. So I'm going to just force that to be in limit cycle for now, and then obviously I got my upper and lower limits is valid, and also my overshoot suppression is also valid in bit 7. And then I also have a hunting suppression. I recommend go and read up on the hunting suppression, because it does work differently for different configurations of the PID. That's, for instance, if you've got a broken wire, or you just got unreliable temperatures coming in, then the PID will be able to cater for those anomalies that takes place in your measurement. Okay, so without wasting any more time, let's go and have a look at the PID and the PLC. I've got ourselves a PLC setup here, and let's see what's going to happen. At the moment my temperature is at 100. I'm going to cool down. I'm just going to simulate my cooling down, and then you can see what happens. I'm going to get my log viewer in here as well, so we can see how it looks like. Where are you? Let's see. Okay, let's do that. Okay, So I'm going to go to my PLC and adjust the temperature. So I'm just simulating the temperature through my GOT. It's easier for me just to play with the temperature because I don't have a physical element with a temperature sensor. So, but we will be able to see in the log viewer what's going to happen. So what I'm going to do with the log viewer is I'm going to zoom out on the log viewer so that we can see a bit more detail as the data collects. So take note there that I've zoomed out. So that's where I basically switched that bit 8 on in the PLC. Just take note here in the program that I've just moved some of my bits to M registers because your log viewer cannot record word registers .0, for instance, if you've broken your word up into bits. Okay, so you have to record actual M registers. Okay, so now my temperature is down to 44. We can even drop it a little bit lower down. And let's say we're roughly at room temperature. There we go, 26 degrees Celsius. And take note of the function that I'm going to use. I'm going to show you in detail just now of what I'm doing here, because you can't see what I'm doing at the moment. So I'm just reformatting the graph so that we can see what the temperature is. That is what I've done now by hand. I've changed the PV to drop the temperature down to room temperature. Okay, let's start the PID. I'm going to do exactly what I just shown you now in the program. I'm going to start the PID in auto-tune mode. Then quite a couple of things should happen there on the go. So I started the PID and my PID generated an error. It normally happens because the KP value is not true. I'm just going to stop the PID for a moment. You will not affect your other PIDs if you got more than one PID running in your system. So I'm just quickly going to reset my PLC error, clear the PLC error. You've noted that the error is now gone. And I'm going to do just a restart on my auto tune, and the PID should be happy now by starting up. So there we go, PID started up. You can see there on the HMI that MB is trying its very best to heat up the element. You can also see on the log viewer there that our output is a bit more active. So I'm going to zoom in a little bit so you can see a bit more detail. Okay, and I'm changing the temperature now, because now since the MV wants the temperature higher, the temperature needs to go higher. Okay, so I'm just simulating the temperature going higher until the PID realizes that we're more or less close to the value that we want, and then the MV is switched off, and it's going to do that for about 3 cycles. So the MV wants me to drop the temperature now. I'm dropping the temperature just below the set point, and then the MV wants me to rise the temperature again. So I'm just simulating it very quickly. Let's say this is a small element with a temperature sensor. Now the MV is down again, and as it goes down, and one more, and the PID should be auto-tuned. Okay, there it's auto-tuned now. Okay, so the MV is busy monitoring the temperature sensor. I'm just jumping temperatures quite rapidly because I can't manage it very accurately. But let's see what the MV does on that take on 100.4 degrees Celsius. Okay. You can zoom in on the log viewer. I'm just going to give us a better view on that. Okay, so that is all what has happened right now, and now I can merely just sit here and look at the log viewer and understand what has happened with the process in my PID. Extremely powerful. So I'm going to stop the log viewer now, and I'm going to zoom in and I'm just going to reformat my data with the icon in the top there. Okay, and now you can see in more clear detail what the analogical values has done, what the MV has done. The MV is the red line, the PV is the white line. There's my bit 4, which is my auto tune bit. So right there in the beginning, that's where the PID started. So it started in auto tune mode, and the MV said, listen, you need to give me some temperature. I gave it some temperature over there. When it got to a certain temperature, we can actually put on some cursors here, and I'm going to put a red cursor there, and I can move it around and take exact measurements in exact time. I can even add a second cursor in there, multiple cursor labels, and I can put a blue cursor at that point. And at the bottom, you can see the time duration between the switches of that bit. So I can even go deeper in and zoom right down to the pulses where my output is operate my Y output. And I can give you the exact timing for how long that output was on. So I can just move my red cursor over there and my blue cursor over here, and that roughly took me about 17 milliseconds. Okay, so that is solid state relay would have been on for 17.320 milliseconds. Okay. Even go further down the line and see what happened with the output. Let me just zoom out a bit to get more detail. Okay, so there we can see what the output has tried to do based on what the MV is doing in the circuit. So, and you can comfortably come and do your measurements. You can scroll your cursors back and forth, and the time will be automatically updated at the bottom, so we can see how long the solenoid was on, and I can reflect back to see exactly what has happened with the data during my recording. So there's my temperature, and there's my MV. So there's a PV and the MV, and based on that logic there, I can see my temperature there was this peak was at 110.3 degrees Celsius, and that side it was 109.4 degrees Celsius, and the MB tried to get it on there, but so now don't take this by verbatim, because I'm just simulating with my finger to well, I'm simulating the analogical value by hand, so that I don't see true value. So when you do a proper recording, I'll show you just now. I'll bring the log viewer back into view again for us, so we can play nicely with it. Let me just get back to the main screen. Okay, so there we are on the main screen, and now you can see what I'm doing with the log viewer, and we can zoom in and out to demonstrate for you what's going on here. Okay, so on the left top corner, you have these two buttons. They will reformat your chart for you when you get fresh data in. So if your data go higher than, let's say, 1175, then you'll see the line will stop there. But it's not that it has thrown any data away. It's recording in the background. It's just for your view comfort. You can just click on the button and it will reformat the scale for you there. And there's a couple of other buttons in here that will give us that will widen the graph. This one will narrow the graph. that one will move the graph up and down. So you can actually just take a graph and literally move it up and down. I don't like that one there, I like it rather there. So it's extremely dynamic, very easy to use, very intuitive, no complication behind this. It's a straightforward tool, and you can do tremendous troubleshooting on a level you've never done before. Okay, so find issues in your system. Maybe it's a simple thing that you've written in your code that maybe just moved something too early, or maybe an input from a field comes too early or too late, depends on what your program is supposed to do. And you can very clearly identify anomalies in your system. So just to give you an idea of what's happening here. Okay, so on one end it was on for a long time, another end was on for a very short time. So yeah, so when you see the PID run, let me show you some real data recorded during a PID tune. Let's get to the files quickly. And that's actually very intuitive to have a look at the real-time data recorded off a system. And then things start to make a lot more sense when you work with the log viewer. Yeah, and you'll see the difference immediately on your plant when you work with the log viewer in your program. Almost there. There's this project, there we go. So let's see, what did I record here? There's a sample. Let's see what the PID has done in this sample. Zoom out completely. Oh, that was not a very good example. I was busy playing there. Let me just load another one up. Okay, here's the PID data. It's quite a substantial amount of data that I've recorded there. Okay, there we go. So I can zoom out and get some very interesting information out. So on this specific system, there's 5 PIDs running. And I've recorded the first 3 just to monitor some set points and what the temperature is doing based on the auto tune. And if I'm not mistaken, the auto tune was started somewhere about here or earlier. No, the auto tune was started much earlier. I just recorded halfway during the auto tune. Okay, and you can see at the bottom there how the relays are switching on and off, the solid state relays, and when the PID has reached its peak and how it cools down to a certain point. Okay, and I just took a very large recording there. Maybe there's another one. Let's see. That one should look a bit different. If I zoom out, what did I do here? Okay, so at this point the auto tune started over here. I can actually see my time interval from manually starting the auto tune. You can write your program obviously to start your auto tune automatically. You just grant some time for the duration for temperature changes. So the auto tune started at this point. It heated the element from a certain temperature. Let's have a look what the temperature is. So the temperature was there on 120 degrees Celsius, and the MB kept the temperature on for a certain duration, and it carried on heating up until that point. But because of the size of the element, the temperature still rise further, and that's what the PID wants to learn to know about the specific element and temperature sensor, obviously, in conjunction. So then it's going to cool down to a certain point, and then the PID will take over again. I didn't record enough information here to see the full cycle, but that's what you would see. Okay, so your temperature will rise up, your element will switch according to certain time intervals. Okay, I'm going to see if I can see what happened here. Okay, you can see there the element was off at this time. We put a cursor there for us. I'll put some multiple cursors in because I got them, and put a blue one. So between those 2 points there, you can see what the output has done on Y24 in this case. Okay, the green line corresponds with that output on the MB there. And then you can see how the MB has calmed down, and you can see also the output has reduced the on time for that element. Okay, so it's going to do that for 3 times, 3 cycles. That's now the PID side. But the purpose of this is to show you what you can do with the lock viewer. And I've run over time a little bit today. I hope you've enjoyed that. And you're welcome if you've got any questions on this. Okay. And we call this quits for today. Go to our website. There's loads of information that we regularly update on our website. Go and view our support link. You'll find a lot of things in our knowledge base that will most probably help you in some of your projects. Lots of samples, and we update them on a constant basis. And we got one for Android, and we got one for Mitsubishi, and just browse through the website. There's lots of links. All our products is listed here. We do have a substantial amount of products that you can have a look at to see if it will fit your business needs. Okay, so with that, I'm going to call it the day. I don't see there's any new questions that come in. Anyways, thank you very much for sharing your time with us. And I hope you've learned something today. Please like and click on that subscribe button, and also click the bell icon so that you can receive notifications and not miss out on our live webinars. The next webinar will be about the CPU diagnostics. I'm going to go a little bit more in detail on the CPU diagnostics. There will be also a sample program which I'm going to generate errors and stuff in, so that we can see where these errors come from and where to find help and assistance to resolve those errors. You really don't have to break your head about anything in the PLC. It's very well described. Certain things happen with for a certain reason. You'll get strange errors, and you probably would not know where to start finding it, just because you don't know about the device. Yeah. But I'll explain that for us very nicely. That'll be the diagnostics tool in Works3 at 11 o'clock Tuesday morning. If you have any suggestions around this presentation or presentation topics, please email Samantha B at android.co.za. I'll say that again. That'll be Samantha B at android.co.za. So we look forward to host you at another of our events, and thank you again. And be sure to like, subscribe, and click that bell icon. Goodbye and be safe.